challenging sometimes in the recent tables, right? So the first application that we're going to do is the area under the graph, right? You'll recognize that this area is between the x-axis and the function, right? That's okay? It could also be on the y-axis. What will change? Nothing really, but what changes here is that the function must be in terms of what? It'll be in terms of y, right? And you need the limit for y. Are you okay with that? Yeah? So that's the integral of that. What about if you have something like this? Instead of doing the integration on the top and then the integration on the least and minusing, how do you get the shaded area here? What's the short way to get the area here?
Blocks. Blocks.
County? They have no units on the axis. They have no units, so you're going to count the blocks. Right? You have to integrate between B and A, but how do you know which one to minus? One on top, right? So you have to figure out which function on top. In our example, the function on top is f of x. So it's f of x minus g of x with respect to x. Are you okay with that? Right? So the f of x function has the bigger area. So f of x is here, g of x is here. All right? That's based on their labeling, right? So yeah, you have to be able to use that, right? Right. What happens when you have to find the area below the axis? What will happen there? The area here is negative, right? So you have to pay attention. Let's just say I want the area of this here. Let's say here is C and here is D. How do you find the area of the entire thing? What you do? Can I integrate between D and C? Can I integrate the whole function between D and C? No. You cannot do that because this part here is negative. Are you okay with that? Here what you have to do. You have to split it up. You have to split it up. So you integrate between D and C, sorry, A and C.
Yeah.
Then you integrate between B and A, but you have to put a minus sign. And then you integrate between D and C. Are you okay with that? Zachary? Remember the part below the axis, Zachary, better put a minus sign in front. Yeah? So the part below the axis must have a minus sign in front. Okay? So how you would know the part below the axis now? If they don't give you a graph. Yeah, sketch it. All right, so you gotta be able to sketch your functions, right? Right, Sarah? Right, and next we could put it as right modulus, right? Next, formula for volume rotated pi integral between b and a of y squared. Same thing from CSEC. If you have to rotate two functions and you just have to rotate this area here, then you minus the one on top from the one underneath, right? If it's the y-axis, pi by x squared with respect to y, right? And then we're going to look at differential equations. I think I showed you this last week. Can I show you this last week? Adam, I'll show you this. Right? I think I showed you how to separate the variables last week, right? And Anya? Right? So you bring the dy on one side and you bring the dx on one side, and right? And we'll do a couple of problems. Suppose you have d2y dx squared, you have to integrate twice. And you're going to get two constants, right? All right. So that's the application. Let's do a few. Right, we're going hard one time, right?
Now, that's what I
Alright, you all ready? So first one here, they want to find the area of the shaded region using integration. Right? Right? What's in next week besides integration? Like it. Find the length of the lines and using here triangle, right? Or you can count the or Heron's law. Alright, ready? Are you ready? Right, first thing first. We need to find out we need to know which line, which equation goes with which line. Alright? So if you look here, you have three equations. Right? And you have three lines. 1, 2, 3. Question. What do those three lines? What do those three lines? How are we going to figure out which is which?
So
Yeah? Put that's the equation of a line, nice. So here is y is equal to 3x minus 7. Here is y is minus x plus 9. And here y is 1/3 x plus 1. Right. How that gonna help now? What you would recognize, what can you tell me about line AC? What type of gradient is that, Joseph? A negative gradient. So the line AC is which equation here? Second one, very good. Y is equal to minus x plus 9. What about the next two? AB. AB has a positive gradient, right? But which gradient is larger? AB or BC? Who has the larger gradient? AB or BC? AB. So which of these remaining lines says AB? First one. Y is equal to 3x minus 7. And we know what BC is, right? What do we need next? We need A, B, and C. How we get in A, B, and C? Solve simultaneously, right? Solve simultaneously and you get A, B, and C. How do we get the area after that? Huh? Right, but before we integrate, Sahara. Mikhail, sorry, Mikhail. Yeah, Mikhail, how am I gonna get the area? I can't just integrate all of them. There's something I had to do before. Huh? What to do? Alyssa? Alyssa, right? Any guess? What we might have to do is break it up. You're seeing that? There you go. Can I integrate this line and this line between A and B? Yeah? And I'll get the area in the middle. Can I integrate AC and BC? Right, between A and C? No? What's here in case you lost, right? In case you lost there, let me do this. Let me do this. Let me do this. Right? We will figure out this point in a little while, right? We'll figure out this point in a little while here. And then we'll figure out this point in a little while. Right? Can I integrate these two lines together? And then can I integrate between these two lines to get this? Yeah? Go ahead. What's your integrated? Equations. So you're minusing these two equations and integrating them. Right? I gave you the equations already, right? Here is y is 3x minus 7. Here is y is minus x plus 9. And here y is 1/3 x plus 1. Go ahead. All right, online. So I was telling them here, when you find A, B, and C, you will know the x values. And then you're going to integrate between here and here. So you're going to integrate this line minus this line between here and here. Right? And that'll give you here. Then you're integrating between this line and this line to give you the area here. And then you add them up. Go ahead. Find it fast. Huh? You want to find them? That was a proof. So you had to show it. Solve them simultaneously and find the coordinates, please. Who lost? Right? So when you solve these two, you will get it pointed. When you solve these two, you'll get it pointed. When you solve these two, you'll get it. You okay with that? Right. To integrate, when you get the boundaries, you're going to minus them, because remember I showed you this rule. Like if you have this function, you want to get the area here, you minus the one on top and the one below. So you minus this line, and then integrate here. Minus this line and this line, then integrate them between those limits. Yeah. Right, but you can do like applied if you want on trapezium, minor. Right? Trapezium, minor. You can do that if you want. There's a straight line, right? Yeah. Hurry up. Solve it fast.
So if the line was, you will need x dash.
Then you can keep it negative so far. So if this happens to be down there, you're going to have to do something.
It would have been accidental.
That's why you're just waiting on it. That's why it's when you have 2 years last to change that.
Yeah, I feel like when I was doing something fast with this area, I was starting out things, but now I think they would have to really.
But it fixed it afterwards. The pictures came question later. Because that was something you had to consider as well. But the points were positive about it. So that's why they left it with the line. I think all the solutions were positive. But there was our next one, and one of the years that I put it up when I was 27. I should my brother was one of that. You're done? Solve it fast. You all remember the labeling A, B, C?
Which one?
A, B, C?
Yeah.
Yeah? You sure? No, I was asking you. No, I can't remember the year. The year is 2015. 2015, here is A, here is B, and here is C. Right? When I worked out A, I got 4.5. When I worked out B, I got 3.2. And when I got C, I got 6.3. After I solve it. Right? So here is 3, here is 4, and here is 6. Right? So find the area from a place. Yeah. Or I don't think anybody take in one of the half, yeah. If you are ready to have it, so put it over brush or something.
There's a city crash course.
Your. I do, I never said.
You can get the 50 minutes space and be honest. Yeah, fine.
Some of you, they have people who sign up on the outside for the education. Or they have food served from that, why they have.
Yeah, bro. At towards the next round.
Who work with them, crash course.
Yeah.
Now, or night, Thursday. Crash course start now. Next 2 minutes. That's how they know.
Yeah, that's
Yeah, next week no class, after that, crash course stuff. Right, I will send I mind, I need, for some of them.
I need to check this out.
Please remember to sign up for the crash course, you didn't do it, right, first we will just start. They don't want. Huh? Sign up because of that class full already, so
Yeah, I was fine.
our hardest to call people who don't know. Not say the lesson, just me now. Huh? Someone like that, I'll put more chairs in the back, the long tables, you can never come yourself.
Yeah, yeah.
They have long tables in the back. But you came to see that? Right, so it should be here already. So you're integrating between 4 and 3. Right, you're integrating, which one on top? Which line on top? This one, right? So you're integrating 3x minus 7 and the one underneath. 1/3 x plus 1 with respect to x, right? For a big bracket here, so you don't mix anything up. Add it to the integral between 6 and 4 of the one on top minus x plus 9 minus the one underneath 1/3 x plus 1. Right? Remember, you can put integration straight in the calculator, so you can compare answers, right? Compare. Again, comparison. What again? So, why just count the blocks and Nine minus 1 is 8. Minus 7. Oh, Miss Standard Communication Studies is the Friday, April 10th, half 8 to half, 2.5 to 300, right? No, I think he pushes the down. So resting a little by Sasami or but this next post now. Forget about before. Huh?
He knows that this is good.
Huh? Right, remember after crash course on us open, right? If you want to come and work any day, I'll tell you the days again, you can come and work, right? Okay, and if you want to do integration, we'll come and that's all, right? Don't think after crash course already playing now. You'll forget. Alright? So. You just tell me what you want to come and do. I'll tell you which days and we just practice. Right then.
So yes.
Especially those who do pure private.
Oh yeah.
I have one ball in the passport. I don't really
I
have.
understand this.
But if you want, just come over here and I will.
I can't make it.
Anybody plug any values already?
Yeah.
Final answer. Anybody else get that? 23.
Up fighting.
Huh?
Up and fighting.
Did it fight it?
Yes.
Oh,
Fight is
I could say fight it was November or October.
That's it. 314.
Oh, okay.
Says cheaper.
True. I don't really know that every day is something, you know.
So, what digits in all my?
3.12, I don't know. I never really know that. Huh? 100 and? I don't know what that's all. Online, are you okay with that? You all okay with us? Try this next one here. This is 2018. Let's change it slightly. Follow that one. There you go. So when exams on, come on, you do some more of this, right? When you follow Antonio, I just minus 90 and just plug in the value. I didn't do it, but plug in the 4, work it out, plug in the 3 and minus. Right? Right, question. Next one here. What's this here? This one here is a differential equation. So let's read the info. Let's read the info and see if we can create an equation, right? This is 2018. This came in 2018. The slope of a tangent. The slope of a tangent of a curve G at the point XY is equal to the product of the X and the reciprocal of the Y. How are we going to write that? Dante, how is write slope of a tangent? How is write slope? Gradient. How is write that? No, we don't differentiate. Well, creating a differential equation. So you're right, dy dx. Right, Adrian, next part. They said the slope is equal to the product of the x and the reciprocal of the y. How to write that? Multiply by, which is 1 over y. Right? So you end up with dy dx. Right? And they want you to find it at the point. Right? So I just removing this, right? Right. So they want you to solve this. How are you solving this here, Jordan? Remember? Help him? Adam? We did this last week. How you solve first order differentials like this? Ready? For what? Huh? Right. Put the y on this side, put the x on this side, right? So you have to separate the variables. Okay? Separate the variables and solve that, please. Right? Separate the variables, solve it, and they want it They want the equation at the point here. Right? So separate the variables. Just one line or two. One parent. Right? Separate the variables and integration.
Yeah, that's it. Yes.
Oh yeah, separate and solve. Solve for y and then solve for separate the variables, get it like last week.
I think it's all it's all yeah, that's all for it was by was by
Oh yeah, separate the variables and integrate. Oh, did you say me last week? Yeah, you said one last week. Alright, well, you should be able to get it. I'll give you an next one. Huh?
I want to make sure to crack.
Did I give you this one last week? I know.
Actually, yeah.
I did?
Actually, this is.
Second. Okay, so like she right, I'm not laughing. Oh, yeah.
I didn't say that.
Fine.
This one.
Okay.
That's the music example.
Right, so you separate the variables, you'll get y, dy is equal to x dx. You have to integrate, you'll get y squared on 2, x squared on 2 plus c. Remember I explained to you why I have one variable only, one constant only, right? And then you want to find for c. And if you want, you can multiply everything by 2 if you want. You know, like the way it's looking. Right? And then plug in 3 and 1. So 3 squared is 1. They gave you this, question gave you this. I just take it off, right? 1 squared plus 2 by c. 9 minus 1, I got c to be 4. Yeah? So the equation is y is equal to the square root of x squared plus b. Right? The reason you play it like this is normally there's one y in terms of x. Okay? Nothing wrong with this here. No. Because you solve it here. That's good. So if you have y squared is x squared plus a. Right, let's do one next one here.
Get meeting for yes, it's like compression. Yeah, but real way of pay. Real man looking.
Right, this one here. The slope. Right, the slope of a function. The slope of a function is defined as follows. The slope of a function is defined as follows. Find the equation of the Find this equation given the following, right? The slope of the function looks like this. Right? So they give you this, right? Solve the equation here. I didn't give you this one, right? As I was asking. Good. So this combines what we did last week as well. You all remember we did integration by what? Substitution, right? So I'll give you a little hint there. As you can see go now. That's what I'm looking for. Those didn't happen in the book. Yeah, I'll do now. I've done.
This. Which I use. Sorry. Let's see.
Make a substitution, right? And I'll sure that right. Yeah, it was correct. Right, so when you separate the variables, you'll get y dot dy is x by the square root of x squared plus 1. Right, so we're going to focus on integrating here. So, right, I'm just pulling this out for now, right? So I want to find the integral of x by the square root of x squared plus 1. So let u equal to x squared plus 1. So you have du dx is equal to 2x. So it means that dx is du on 2x. So when I make my substitution here, I'll get x by the square root of u, du by 2x, and the x will cancel. I can pull the half on the outside and then begin to integrate. The integral of u, the integral of the square root of u is u to the half plus 1 all over 3 on 2. Right, so therefore what we'll end up with, when I integrate, I'll get y squared on 2 plus, y squared on 2 is equal to 1 on 3. No, it's not, it's 1 on 3, right?
Yeah, on the tree.
1 on 3 by u, which is x squared plus 1 to the 3 on 2 plus 6. Okay, I should have write that back here for you, right? 1 on 3 by x squared plus 1 to the 3 on 2. That's okay? Right? If you want here, you can get rid of your fractions, it's up to you. You can multiply everything by what, 6? So you'll get 3y squared is equal to 2 by the square root of x squared plus 1 cubed. Right? Your square root and then you cube it plus 6c. Question said when x is equal to 0, y is 2. 2 squared is 4, so that's 12. This is 0 by 1, that's 1, that's 2 plus 6c.
X is. It's 0.
There's 0, right? 0 plus 1 cube is 1, that's 2. 2 plus 6c. What do you got? What do you got for c? 5 over 3. Okay, good. So I have 3y squared is equal to 2 by the square root of x squared plus 1 cube plus 10. That's okay? Right? If you get confused here, all I did when I reached here is I multiply everything by 6. You like fractions? I do like it. So I'll multiply it by 6, 2 by 3. So multiply this by 6, this by 6, this by 6. Right? And then I plug in these two bars. Plug in 0 and I plug in 2. Right? And I solve for C. Next one.
Next slide, 6. Six. Okay. Yeah.
Earlier, what's the integral of this? What's the integral of 1 on v with respect to v? I gave you this, right? Ln v, right? If you have to integrate 1 on v is ln v. Okay. All right, go ahead. Try this one. I told you for a reason, right? Because you'll need it, right? Try this here.
I think a picture. Yes. Section. I didn't believe that you should put it. I think lights, water, I think water and water. Oh. Yes, you can vote. Okay. So yeah, just. Yeah. No, sorry, about my negative. Yeah. Oh, actually, the same answer. Yeah, I think that's. I'll do a little vote. That's we can start. I don't get my inside.
Right, so when you separate it, right, remember before you separate it, you have to put them on both sides, right? That was 2.5, right? 2.5. So bring the V on this side, you'll get 1 on V dV and leave the minus 2.5 here, dt. Right? You move it here, nothing wrong with that. Yeah, but. So you bring the V here, you'll get 1 on V, and you bring the dt on this side. Now we're going to integrate. What's the integral of 1 on V? Ln V. What's the integral of minus 1 over 2.5? Minus 1 on 2.5 by t plus c, right? There's 5 on 2 pips, right? Right? So that'll be ln V is minus 2/5 T plus C. You want to find C. So when question said when V is 25, T is 0. Right? So T is 0, so it means that C is ln 25. Leave it like that. So you'll end up with ln V is minus 2/5 T plus ln 25. Right? But you want to make Y the subject, right? So what do you do with the ln? Move it across. When you move ln across, what you'll get? E. Right? When you move ln across, you'll get E. So you'll get E to the minus 2/5 T plus ln 25. Everybody get some how to simplify this? Right, before I go there, right? Everybody okay up until here? Follow how I got C is ln 25. Follow how I get this? So the integral of 1 on V is ln. You gotta learn that. Right? So the integral of, check out the rules I gave you. Yeah. But then where did V went? Where did V went?
Yeah.
Right, remember you had to bring all the everything here. You had to bring all the V's here. So you're bringing the V here. And you can leave it, if you bring everything across, it will be 2.5 over V. So you will get 2.5 ln V.
I guess he is one thing. So
So I plug in V is 25 and I plug in T is 0. So I get ln 25 is C. Trouble? No, behind you. Trouble? Which one? You follow how, or you don't understand how I get it? You don't understand how I get it? So I have dV dt is V over, where did V have to go? On this side, right? So if it's multiplied, it becomes divide, right? So it becomes 1 on V. And then when I move dt here, I'll leave in this here. So I move across the multiply, it becomes divide, right? And I leave in the 1 on 2.5 right there. And I get this. Right? Right. But when you reach here, we're not done. You should make it look a little bit nicer, right? So watch this here. What does plus mean? Plus means that you would have multiplied, right? So you're multiplying E ln 25. What's E ln 25? E ln 25 is simply 25. So I can bring the 25 here, and my equation actually looks like this. Much nicer, right? 25 e to the minus 2/5. Copy it down, let's go again.
The second is how one of these out. Yeah. One of them. Oh, yeah. How do we have big, you know, we don't need, we should, oh, no, it's like, when it's too small. So it's back to when it's small. You got one on one away variables. These are all in. Yeah, the one thing they pop up by not one of you. Okay, well, yeah, you put it back.
Then it's gone now. I think I'll keep it up to a little bit of- I can see. Anything to recall, man? That's technically my future. I checked it, but I'm gonna go down every street. But like, some of these questions, it's always easy to know, at least the basic integral one of them. Next one, let's go again. Nathan, how far you reach? Okay, yeah, I know for it up, so you should know it. Hi. Thank you. Right, we doing B and C, yeah? 19. Get more? Oh, yeah, try that there. They told you what F of T is and G of T. Show that you can do it separately or you can do them together and get the same integral.
I just lied. Yeah, so this would be safe, yeah.
Right, integrate the left side, integrate the right side, and it should be equal. Which separately, right?
That's why I said one fifth. So, yeah, yes, we leave it in the front.
Integrate F of T plus G of T. Right down, and let's go for that.
But I think it's a lesson to know that. I'm in this with a lot of demand. Yeah, and you can always with exactly balance it out. You know, so if you do the maths and see, we have big big. Yeah, next, so next. Well, we got it. But that's not like, yeah, we did.
Right? Are they equal, left side and right side? When you integrate the left side again, this, when you integrate the right side again, that, right? Nothing really, right? Nothing really to do there. Add them together, integrate. Add them together, integrate, and then integrate them separately. You'll get the same answer, right?
Yes. I mean, it's good. The answer, not something that's probably. Can get it to 20%.
Right, Nathan, which part of the graph we were creating here? Yo. Right, so we rotating y is equal to sine x. Right, we rotating the function between pi and 2 and pi, right? And the x-axis, of course. Okay, so you're rotating this piece of the graph alone, the shaded part of the graph. Hurry up. How you integrate sine squared again? How you integrate sine squared? Okay. Remember you're looking in radians, right? I'll put one on the board because otherwise. Yes. Fine.
Yeah.
Right, so you're integrating between pi and pi of 2, right, of y squared. Y squared is what again? Sine x all squared dot dx. Right? How you integrate sine squared again? Right? Remember, we could use the identity. We could use the identity cos 2x. So we know that sine squared x is equal to 1 minus, sorry, well, a half minus a half plus 2x. So we're really integrating between pi and pi of 2 of 1/2 minus a half cos 2x. Dot. Cover that, yeah? So I use the identity to integrate this. Right? I think we did this exact one. What's last week? We did this exact thing. If you write it down. No one other one, I will write it. Anybody get 5 squared on 4? How much you get on? Final answer. How much you get? Final pretty good. How much? 45 on 5? 45 5. Right? What's the integral of a half there, Adam? A half x? Nice. What's the integral of a half cos 2x? 1/4 sine 2x. Right? Remember, it's 1 over the differential of this, right? And then you're plugging in pi on 2, right, Adrian? So and it's 0. Sign file 0.
Sorry. Yes, let's go. Yes, yeah.
Huh?
No, not right. Go to jail. I'm outside with the chairs.
Check vacancy now.
I didn't get signed first, man.
Huh?
This one's
Yep. Work it out quick. Can we do one more?
No, we are going to that.
Are you okay or one more? Huh?